Hi everyone, we're just going to be giving it another couple of minutes to allow the rest of the attendees to join, and then we'll get underway. It's 2 o'clock, I'm just going to give it one more minute. Brilliant. So we'll get started. I just want to say, firstly, good afternoon to everyone. Thank you very much for joining us for this webinar, the importance of calf health and nutrition. So this is the third and last in our mini three-part series of the Future of Milk Production series of webinars. So my name's Cassie McCready. I'm the Business Development Manager for Livestock at the Agri-EPI Center, and I'm going to be your host for the webinar this afternoon. So we're delighted to have partnered with two of our members for this webinar, so that's SRUC and VOLAC, to bring you today's event. So before we get underway and I introduce you to some of the speakers, I'll just go through a little bit of housekeeping. So please note that this session is being recorded. All attendees are on mute and in listen-only mode. Questions will be taken at the end of the presentation. You can submit these throughout the webinar via the questions bar on the right-hand side of your screen. So we would love to hear from you throughout the presentation, so please do interact with us also via the chat function. So today we welcome Dr. John Newbold from SRUC, Dr. Jessica Cook from VOLAC, and Duncan Forbes from Agri-EPI Center. So without further ado, I would like to just take the first 5 minutes of your time to introduce you to Agri-EPI Center and who we are. As I said, I'm Cassie McCready, Business Development Manager. So who are Agri-EPI Center? So we are one of 4 agri-tech centres in the UK, set up in 2016 by the Department of Business, Energy and Industrial Strategy and funded via Innovate UK. Our sister centres include Agrimetrics, so the big data centre, CHAP for crop health and protection, and CL, the Centre for Innovation in Livestock. And we exist essentially to deliver benefits to UK farming via the uptake and innovation of agricultural technologies. So we're centered around a membership offering. We bring together all kinds of different members, so academic institutions, sorry, I've just lost my presentation there, academic institutions, tech developers, whether that's biotech or digital technologies, farmers, processors, retailers, engineers, industry bodies from the sort of wide spectrum of the agricultural industries. We operate across arable, horticulture, livestock and grassland, aquaculture, and cross-sector technology, so a really broad offering. And what is it that we do? So we have 3 main objectives. One is to bridge the gap between the supply chain to operate a wide range of industry-led activities in R&D, demonstration, training and education, and to ensure that all knowledge is generated, is exchanged and transferred throughout the industry. So as an Agri-EPI member, you gain access to leading academic institutions and the knowledge and expertise that come out of those. We broker collaborations and build consortia to apply for funding. Throughout your idea, we test and demonstrate new technologies at our centres of excellence on farm facilities up and down the UK and globally. We help you access and apply for funding for R&D. We have business incubation and workshop facilities via our Midlands hub. We do KE and dissemination through events, including the whole of industry, and we have a team for influencing policy. So just to give you a little bit of idea about our network, you can see from this map on the left, so the red dots there are what we call our 4 main hubs. So we've got the one at the top is our northern hub, and that's up in Edinburgh. Moving down to the Midlands in the west, we've got what we call our Midlands Hub, and that's where we've based our business incubation facilities and workshop space. We also have our Midlands Dairy Research Centre there, which Duncan Forbes will tell you a little bit more about later. Moving over sort of a little further south and towards the east, we've got our Cranfield Hub, which is our phenotyping gantry. So this is essentially our crop centre of excellence. Moving down into the southwest, we've got our Southwest Dairy Development Centre, sort of our flagship livestock facility, which Duncan Forbes again will tell you a little bit more about later. Moving on to the white dots, and this is sort of the really unique part about Agri-EPI. These are our satellite farms. So as well as our research facilities that we have that Agri-EPI own, we work with a network of 24 commercial farmers to test, validate, trial and demonstrate new technologies in real world commercial settings. So that's all from me. Just to let you know, we are running a campaign at the minute, AgriTech Enabler. So do engage with us on social media. We're on LinkedIn and Twitter. Please use the hashtag AgriTech Enabler if you are going to tweet about this webinar or anything in the future that involves us. Retweet and share our campaign post through your own network and let us know if we can help you out by tagging you on social as well. So what I'm going to do now is I'm going to hand over to John. So Dr. John Newbold was educated in agriculture on his grandparents' farm, the University of Nottingham and Michigan State University. So John has had a 30-year career in R&D and technical positions in the animal feed industry, working in the UK and internationally. In August 2019, John took up the position of Professor of Dairy Nutrition at SIUC, so Scotland's Rural College, based in the dairy heartland of Dumfries and Galloway. John is keen to work collaboratively and broadly across dairy farming, the agricultural supply industries and academia, understanding and applying science to improve the efficiency of conversion and primary natural resources into nutritious, healthy and delicious food. So with that, I am going to hand over to John. John, I can see your screen, so please go ahead. Sorry, John, we can't hear you there. Can I just ask you to unmute? Sorry, John, still struggling to hear you. Nope.
That's better. Okay.
There we go.
There we go.
Thank you.
Apologies for that. I think I was trying to unmute myself and Cassie was trying to unmute myself. And anyway, there we go. And hopefully everybody can see the screen and let's get started. I've only got 15 minutes, so can't hang around here. I'm going to talk a little bit about calf gut and respiratory health. And I thought I'd introduce that by talking briefly about the project that's underway at the Crichton Calf Unit at the moment, with the funders that you can see listed on this particular slide for WellCalf, a project being run by my colleague Carol Ann Duthie. It's a good one to introduce this afternoon's session with, I think. It's about precision agriculture, focused on improving health and productivity, and really monitoring very closely the health, the development of the animal from the very early stage in our calf facility, with a focus on early signs and early diagnostics for calf scour and for pneumonia. So it will take a lot of data from sensors, regular weighings and recordings of feeding behavior and so forth, and try to build those into a decision support platform to enable early decision making and early intervention when signs of disease or ill health are emerging. And just quickly onto this last slide about WellCalf, I wanted to point out the impacts looking for this project, really just to reinforce the magnitude of the financial cost of getting it wrong, whether it's suboptimal early life management resulting in poorer than anticipated growth, or the direct impacts of £80 million or so in terms of the impact of disease. So with those figures in mind, I think that well justifies this whole seminar and hopefully the next few minutes about health and respiratory disease. I want to pick this up really from a nutritional perspective. So thinking not just about what's happening in the gut and in the respiratory organs, but linking that back into what the animal is eating. So this little sort of guideline here, from milk to gut development, and then the consequences of gut development for gut health and respiratory health. I thought, by way of introduction, whilst I was looking around on Google and papers in this area, I came across this one, which is actually a human study. Nice place to start. This is work with athletes, endurance athletes, so long distance runners, cyclists, triathletes, etc., etc. This population was split, and some were given a placebo and some were given a supplement of bovine colostrum. And then their respiratory condition was recorded, their upper respiratory symptoms were recorded during exercise training. And you can see from this meta-analysis that on the left of the slide, the left of the picture, the group that had the colostrum supplement had a significantly less expression of these negative upper respiratory symptoms. So again, in a human population, let alone in a calf, we can quite clearly see that milk is doing something that is having a direct and positive effect in relation to respiratory health. Anyway, we're not here to discuss endurance athletes, so let's move on and think about the calf. Introduce that with a piece of data, I think it's Canadian work from 2017. Fairly simple experiment with a group of bull calves, split into two. They're either just reared conventionally on a milk replacer, or throughout the pre-weaning period, they're given colostrum in addition to the milk replacer. The first line in the table here is the serum IgG levels at day 0, so when these animals are being enrolled into the study at the start. These are quite healthy levels of serum IgG, suggesting that both groups have had a success in terms of passive transfer of antibodies from their colostrum immediately after birth. So we've got two groups of healthy calves coming onto the study at day 0. Those calves that were then continued to be given the colostrum substitute, they didn't grow any faster, at least not statistically faster. But if you look at the incidence of antibiotic treatments and the odds ratio of an elevated fecal score, in other words, calf scour, or the odds ratio of an elevated respiratory score, in other words, experiencing respiratory problems and symptoms of nasal discharge, etc. In all cases, the calves that were given the colostrum in addition to the milk replacer had better outcomes in terms of those measures of health. So there's something in milk, something in colostrum that's conferring this extra benefit. Which really points me back then towards milk and towards milk composition. Think about proteins. If you go into the literature and look for milk proteomics, there's a large number of publications in the last few years which will give you long lists, almost endless tables of molecules, protein molecules, that have been found in milk, found in colostrum, and found in transition milk in that period of early lactation after the main colostrum period. And this is just one example table from one example paper, and it shows molecules like, for example, lactoperoxidase and lactoferrin, which have direct antimicrobial effects in the gut of the animal. It has proteins like the complement factors, which support the innate immunity of the animal. And at the bottom of the list here, it has proteins like these protease inhibitors that help to almost look after some of these bioactive proteins and make sure that they're not accidentally digested before they have chance to exert their positive effects. And that's just the proteins. Here's another pretty picture from another paper, and again there are many example papers in this area looking at some of the carbohydrates, or more specifically the oligosaccharides that you find in milk. The chromatogram here is a listing of the range of different molecules that were detected in this sample of bovine milk. These things work from California. And then the molecular diagrams with the sort of blue squares and yellow circles, etc., is just a schematic representation of these different molecules that have been detected in milk. And it's known in multiple species, including in humans, that oligosaccharides in milk play a key role in steering the development of the microbiome in the gut. So simple message basically that whether you're talking about proteins or carbohydrates, and I could add more illustrations here about lipids as well, milk is an exceedingly rich, wonderful treasure trove of molecules, many of which, most of which, can exert some direct functional positive effects. And of course, once the animals consume them, they're going to hit the gut. And again, I want to use this slide just to emphasize the complexity of the gut and the fact that there are multiple defense mechanisms between, if you like, the outside of the animal, pictured here at the top of this chart, and progressing through down to the inside of the animal when materials have been absorbed. So, of course, there's the lumen of the gut itself, where we've got the microbiota with what we might think of as some good bacteria interacting with some less good bacteria. You've got the mucus layers offering an extra degree of protection. You've got the cells of the epithelium itself, the enterocytes, where the tight junctions, in particular between adjacent cells, are critical to prevent bacterial access or the absorption of toxins like lipopolysaccharide. And then further inside the system, again, you've got the interactions with receptor molecules will identify any bacteria or toxins that are present and can then coordinate an immune response. So milk, an exceedingly complex material, interacting with the gut mucosa, an exceedingly complex physiological system. I'm going to give just one example now in the next 2 or 3 slides about how something in milk can steer the development of one aspect of this gut system. And that aspect I'm going to focus on is the gut microbiota in the lumen of the intestine. Stole this picture from Wikipedia just online. This is, in case you're interested, Faecalibacterium prausnitzii. I think I get the pronunciation more or less right, which is a great bacteria, and I hope everybody on the call has got plenty of it because it's one of the good guys. And I want to illustrate this with a piece of work reported here in this 2013 paper. What they did here was using fecal samples at 1 week of age as a proxy for the intestinal microflora. They went in at 1 week of age and quantified a whole range of bacteria. They then divided their data according to 3 terciles, or 3/3, according to the abundance of this particular bacterium, Faecalibacteria prausnitzii, at 1 week of age. Okay, so the first tercile, is the third of these calves that had the lowest abundance of this particular bacteria. And you can see the growth rate in that top chart there, body weight versus time. These were the slowest growing animals. At the other extreme, the third that had the highest population of the Faecalibacterium prausnitzii at week 1 of age grew fastest through this whole 7-week period on the chart. And one other interesting thing, the measurement of the bacteria was made at 1 week of age, but the difference in growth rate that you can see visually on the slide didn't really begin to emerge until later on, the 5th, 6th, and 7th week. In other words, something that was different about these calves at 1 week of age had that longer-term consequence in weeks 6 and 7. And the chart at the bottom here relates this back to the incidence of calf scour, diarrhea. So the first tercile, the third of these calves that had the lowest abundance of this bacteria, had the highest incidence of diarrhea. And those calves that had the highest population abundance of the bacteria had the lowest incidence of diarrhea. And you can quickly read the conclusion that the authors came to about the potential importance of this particular bacterium in that very early period, 1 week of age. And to try to almost sort of complete the story and relate it back to milk, this is a report that some work that I was involved with a couple of years ago with a group at the University of Liverpool, fairly small scale study in which 2 milk replacers, the blue line and the red line, milk replacer 1 and milk replacer 2, were fed to a group of young calves. And again, using fecal samples as a proxy for the intestinal microbiota, we went in and measured, again, a range of different bacteria. This particular chart shows 2 of the beneficial groups of bacteria, Bifidobacterium on the left, and then the one we've just been talking about, Faecalibacterium prausnitzii, shown on the right of the screen. And in both cases, you can see that at week 1, there was a higher incidence, a higher abundance of these bacteria in milk replacer 2 in red compared with milk replacer 1 in blue. Raises some really interesting questions about what it is in those 2 different milk replacers that was doing the steering and causing this difference. Not entirely clear, but we have a working hypothesis that it's the milk oligosaccharides. We know from many studies in other species, including a lot in humans, the importance of milk oligosaccharides in supporting bifidobacteria, and we know that bifidobacteria kind of sets the scene and facilitates the development of the Faecalibacteria, such as the one shown on the screen here. So we've got milk steering the gut microbiome, and we've got the gut microbiome, the previous slide, resulting in an improvement in calf health. Okay, just to move that on a little bit, I want to talk very briefly about what that means for the link to respiratory health. And in the literature, there is a lot of discussion, a lot of papers that will refer to the gut-lung axis. In other words, communication and crosstalk between what's happening in the gut and what's happening in the respiratory system. This picture taken from the paper on the screen here is one way of trying to illustrate that. So you can sort of see at the top of the screen, you've got the respiratory system and the lungs, including the microflora of the lungs, which consist of, as they always do, bacteria, the bacteriobiota, fungi, the mycobiota, and viruses, the virobiota. Lower down the screen, you've got the same sort of representation for what's happening in the gut. There's clearly a direct crosstalk, a microbial crosstalk between the two, given that you know, through the oral cavity and through the nasal cavity, the tissues of the lung and the tissues of the gut are connected. So there is going to be some exchange of microbiota between the two. But in addition to that, the other lines illustrated on this chart, other means of communication, other means of crosstalk between the immune systems, those that are present in the gut, those that are present in the lung. And this is, of course, two-way. If something is being detected in the lungs, the lung has a mechanism to really communicate that information to the gut, and clearly vice versa. The literature that I've been finding and reading around in this area is really relatively recent, over the last sort of 5 or 6 years. And I'm rather surprised that I've not been able to find more in the calf area. There's certainly a lot in the human area. And again, if I may just go back to one illustration for interest, taken from a human study. This is again another meta-analysis, so several studies combined and reviewed, in work here where the human population was given either a placebo or given a mixture of probiotics consisting of lactobacilli and bifidobacteria. And the population that was consuming the probiotics on the left of the screen had lower symptoms of the common cold than the population that was consuming the placebo. So again, some evidence here that an intervention that was affecting the gut through the use of the probiotics being consumed was having an effect on a health outcome measured in the respiratory tract. And I think this concept of this gut-lung axis and the link between the microbiome of the gut and the microbiome of the lungs and the development of the lungs is something we're going to see a lot more of in research over the next few years. Clearly, it's an area of considerable activity and interest. And finally, this is my last slide, last but one, just to mention really the antibiotics and the impact of antibiotics. So if we have these connections shown in blue between what we're putting in with milk and all of its complexity influencing the development of the gut, what that then can mean for gut health and respiratory health, the use indiscriminately of antibiotics can intervene and interfere both with the effects of milk and presumably with the response to what's happening in the gut microbiome. And just one illustration of this, going back to my favorite bacteria there, the Faecalibacteria. This is work done in the US, again, another calf study. There was a control group of calves, and then there was a group of calves that were given the antibiotic bacitracin. And then they were further subdivided into those calves which did exhibit some scours and those calves which did not. And if you're looking at the impact here on this positive, beneficial, good bacteria, very clear and very obvious that the use of the antibiotic essentially wiped it out. And it's also quite clear that the animals that experienced scouring had much lower abundance of this bacteria than those that were remaining healthy. So again, I think this is another driver for the research and continued application of that research in this area, understanding what's going on in milk and what it does. So the take-homes briefly, Health and development, I think almost we need to think of them as preceding performance. In the very young animal, that's our target. Keep that animal healthy, look after the development of the various organ systems that that animal has, and then that calf will reward us with performance that meets our economic aspirations. Secondly, nutrition is the root. If we're going to improve gut and respiratory health, that's what we can do. That's what we can put things into feeds, and we can get those into the animal. And the third thing, which nobody should be at all surprised about, there is far more to milk than simply the content of lactose, protein, and fat. And modern analytical science is really driving considerable enhancements in our understanding of what's in milk and what those components to do. And of course, as you'd expect me to say, there's a lot more research needed in this area. Okay, and I think that's me. Hope that was good for time. Be happy to take any questions later.
John, that was excellent. That was perfect timing. Yeah, and like John said, please do continue to ask your questions in the side panel on the right. So an excellent deep dive there into calf gut and respiratory health, and a fantastic example through WellCalf of how we can use the Agri-EPI SRUC calf facility for this, vitally important research. So I'm going to move on to Dr. Jessica Cutt from Volac. So Jessica grew up on a mixed farm in East Sussex and gained a first-class degree in zoology from the University of Leeds, followed by a PhD at the Royal Veterinary College, London. So during her PhD, Jessica conducted a large on-farm study to determine the importance of factors during calf development on the subsequent fertility, productivity, and longevity of dairy cows. Following a 3-year research post at the Royal Veterinary College in the area of dairy cow facility, Jessica joined Volac in 2010 as their young animal technical specialist, providing in-depth technical support for the young animal products. In her current role at Volac as research scientist, Jessica is responsible for the young animal R&D, building and managing the company's knowledge platform for the young animal sector. Throughout her career, Jessica has published numerous peer-reviewed scientific papers and has had a key role in raising the profile of the calf and heifer within the dairy industry. So without further ado, I'm pleased to hand over to Jessica. We can see your presentation, so off you go.
Thank you very much, Cassie. So this afternoon, I am going to be discussing the role that milk formulas can play in supporting the growth, health and development of calves. Volac have been providing farmers and farming communities with innovative research-based animal nutrition products for over 50 years. We manufacture our own high-performance milk powders, rumen-protected fats and silage additives. Our whey processing expertise allows us to provide blended milk formulas with a unique range of bioactive components, and these are designed to promote the healthy and fast growth in young animals. For today's talk, I'm going to give you a brief overview of our latest initiatives and products and how these can be used on farm to help calves hit target growth rates and remain healthy. Numerous studies have shown over the years that heifers calving for the first time at 24 months of age have the best chance of achieving their full lifetime potential in terms of their fertility, their milk yield, and their longevity. To calve a heifer down at 24 months of age, she needs to be in calf at 15 months of age. We therefore need to start breeding her at 13 to 14 months to allow her to have more than one service per conception. But achieving a target body weight at first breeding and at first calving is equally important as hitting a target age, as she must be big enough. Heifers should be bred for the first time with around 55 to 60% of their mature body weight, and they should be achieving 85 to 90% of their mature body weight at first calving. To give heifers the best possible chance of achieving these target body weights and ages, calves should ideally double their birth weight by weaning. We therefore need to provide the young calf with enough energy and protein from day one to take full advantage of the high feed efficiency that these young animals have over the first 2 months of life, and therefore maximise the growth rate during that pre-weaning period. The nutrition of the young calf from day one is key to it then hitting subsequent targets up until first calving. The primary source of nutrition for a calf during the first 3 to 4 weeks of life is milk, and that is because starter intake is minimal. Feeding more milk, i.e. providing that calf with more energy from birth, will benefit calf performance and long-term development. So it's been shown that by feeding more milk, this will maximise that early feed efficiency and its growth potential. But in addition to the impact on growth, feeding more milk has been shown to benefit health, and that's because mounting an immune response is a considerable energetic demand. So if you feed the calf more milk, put more energy into it, it'll be in a much better place to mount an immune response. Furthermore, feeding more milk and an improved growth rate during that milk feeding period has been shown to improve its future performance, and in particular its milk yield potential. Feed for Growth is a VOLAC initiative designed to demonstrate the importance of age at first calving, as well as providing the tools on actually achieving target age at first calving. It's organised into 4 key areas. Firstly, we need to understand the opportunity that's available on farm and actually how to achieve it. Secondly is about planning, and it's really important to set targets that are specific to individual farms. So for an individual farm, targets need to be based on the mature body weight of cows on that farm and the target age at first calving. And with those 2 pieces of information, individual farms then need to plan their own roadmap and their own targets. Thirdly is about managing, so we need to feed those young animals enough feed to hit the target growth rate. And absolutely crucial to this is actually the measuring and monitoring of growth rate, because if we don't measure growth rate, we don't actually know whether those heifers are on target or not. And then lastly is about reviewing calf performance. So if calves aren't hitting that target growth rate, we need to establish why not and adjust things if necessary. And at this point, it's important to consider more than just nutrition, because the calf needs more than feed to be successful. We need to consider the health and environment of these young animals. So firstly, we need the calf to be healthy, because as I said, if it's mounting an immune response, that's a considerable energetic demand. So all the energy that's going into the immune response diverts it away from growth. And the environment is important as well, because especially young calves are particularly sensitive and susceptible to environmental changes. Calves need to be kept warm, dry and comfortable. So if calves, for example, have got wet beds or environmental temperatures drop below 10 to 15 degrees C, those young calves will actually be using more of their energy simply to keep warm at the expense of their growth rate. New analytical techniques have enabled us to understand a lot more about milk. And as we saw in John's slides, milk is a complex collection of ingredients designed specifically to communicate to the calf. So milk provides the materials for growth, it primes the immune system, it assists in pathogen control, and it shapes the future growth and development of those young animals. Many of these beneficial ingredients are actually found in the whey fraction of milk, and this is why there's so much more whey protein in colostrum than in whole milk. So when we look at the composition of colostrum, whey protein represents 65% of the protein content. That's where all the beneficial ingredients are found in that whey fraction, and that's why colostrum has such a high value to the young calf, as we're all well aware of. VOLAC concentrate the components found in the whey fraction of milk and use them as a base for our milk formulas. So it's a concentrated whey protein and phospholipid base that we call AminoPro. AminoPro supplies protein, fats and sugars to the young calf. So if we consider the protein aspect first, calves need specific amino acids for growth and muscle development, and AminoPro has high levels of key amino acids, and in particular leucine and lysine. It also supplies protein for health, so such as the immunoglobulins that are vital for early life immune development, and lactoferrin, which is a protein involved in the development of the immune system and has antibacterial properties in the gut. AminoPro also supplies fats. Fatty acids are a direct fuel source for the calf, but the special type of fat, the phospholipids, also support gut maturation and have antibacterial properties. AminoPro also supplies sugars, And milk contains a rich mixture of complex sugars called oligosaccharides, and many of these are actually bound to the protein and the fat. Research is establishing in both humans and farm livestock the important role that these sugars play in steering the development of a healthy population of bacteria in the newborn gut. Recent trial work that we have done at AFBI, Hillsborough in Northern Ireland has shown that calves fed a milk formula with a high inclusion level of ImmunoPro grew faster, resulting in a body weight advantage of 4 kilograms at weaning on day 56, compared to those fed a milk formula with a low inclusion level of ImmunoPro. So this really does show the benefits that ImmunoPro brings to those young calves in terms of supplying all of those bioactive components that help to support early growth and development. Dairy ingredients, skim and whey are the main source of protein in milk replacers. Whole milk consists of casein and protein, whereas skim is whole milk with the fat removed, so has the same protein composition as whole milk. So skim also consists of casein and whey protein. Liquid whey is the fraction remaining after the precipitation of the caseins. So you've removed the casein, so it only has the whey protein left. When whole milk or milk replacer with a high skim content enters the calf abomasum, a clot is formed as a result of the enzymes in the abomasum acting upon those casein proteins. When whey is the only source of dairy protein in a milk replacer, no clot will form within the abomasum due to the absence of casein. The development of a firm abomasal clot has in the past been believed to benefit calf digestion, but previous research has also shown that the clotting effect of casein is not required for optimal calf performance. Results of a recent calf trial that we have carried out at AFBI, Hillsborough, Northern Ireland, also supports this earlier research, where we found the use of ImmunoPro as the major source of protein in a milk replacer was equal to the use of skim milk in terms of calf growth and health. So what we did in this calf trial, we had 2 milk replacer diets. One had a high skim content, so 66% of the ingredient was skim milk powder, and that can be seen as the blue bars on this graph. And the other milk replacer that we used had no skim present, and it was all based on our ImmunoPro, so the protein source was the concentrated whey protein. You can see in this graph that on day 56 at weaning, there was no difference in terms of the body weight between these 2 milk replacer diets. So the calves receiving the milk replacer based on a high skim content achieved 73.2 kilos at weaning, and those on the milk replacer based on concentrated whey protein, our ImmunoPro, so no skim was present, they achieved 73.5 kilos. Calf scour is the most common cause of death and disease in calves during the pre-weaning period, and milk formulas can be used to help support calf health. ImmunoGuard is a new product that we have launched this year that has been specifically formulated for calves repeatedly suffering digestive disturbances and scours. So ImmunoGuard is 100% dairy protein, so all of the dairy protein is coming from ImmunoPro. And as we saw on previous slides, the use of ImmunoPro as the source of dairy protein will not only provide the nutrients that those calves need for growth, but it also has all of the bioactive components present that help to prime the immune system and actually assist in pathogen control. Being 100% dairy protein means it hasn't got any vegetable protein present, and that's because this product is designed for calves that will already be expending energy on mounting an immune response. So by being 100% dairy protein means that these calves won't have to use additional energy for digestion. The slightly higher fat content of ImmunoGuard just supplies those calves with more energy. So again, it just gives them more energy for mounting that immune response and having enough for growth. Immunogard also contains Salmonax, which is a hydrolyzed yeast culture with a prebiotic function. So that means that it's actually going to help to improve gut health by feeding the beneficial bacteria that are present. Salmonax has also been shown to have pathogen binding and immune modulation properties. So what that means is that it will help to stop pathogens binding to the intestinal wall, and it will also help prepare the immune system ready for a pathogen challenge. Trial work that we have done using Salmonax found that calves fed milk formula plus Salmonax gained more body weight compared to calves fed a standard milk formula, resulting in a 2 kilogram weight advantage at 41 days. So in summary, it's really important to set objectives that are specific to individual farms, and these must be based on the mature body weight of cows in the herd. And when we're talking about mature body weight, that is for cows in lactation 3, as well as the target age at first calving for a specific farm. Once those two pieces of information are known, individual farms can set their own heifer roadmap, and then we need to feed the young calf enough protein and energy to hit the required target growth rate. We need to use a high quality milk formula, and when we're talking about high quality, the type and quality of the ingredients is important, as well as the processing of those ingredients, which can all have an impact on the digestion of the protein present. So using a high quality milk formula can be used to help support calf growth, development and health. If necessary, use a milk formula that has been formulated to help support calves facing disease challenges. Overall, to get best calf performance, we do need to focus on the nutrition of the young animal, but we also need to consider the health and environment of these young animals, because all three aspects are absolutely key to getting the best out of the calf. Thank you very much.
Thank you, Jessica. Excellent. Great example there of how doing research and undertaking innovation within your products is really key to driving productivity forward in the industry for a more sustainable milk production future. So we're going to move over to our last speaker, my colleague Duncan Forbes. Duncan Forbes is the head of dairy at Agri-EPI Center and has a wealth of experience in the dairy industry. After several years in practical farming, Duncan moved into farm management consultancy and worked for over 20 years as the managing director at Kingshay. In his current role for Agri-EPI Center in Somerset, he's focusing on the development of the dairy research and demonstration facility for 180 cows, combining robotic milking and feeding at the Southwest Dairy Center. We can see your screen, Duncan, so it's over to you.
Thank you very much, Cassie, and good afternoon. Yes, so what I'd like to do today is take you through a little bit of what we've got installed with SIUC. But before I do that, just to cover a little bit of the background to the Agri-EPI Center, which Cassie touched on. So the Agri-EPI Center covers a broad range of sectors, all the way from livestock through arable horticulture to aquaculture. My particular role is within the livestock side is on the dairy sector, and we just need to understand the background as to how the funding was and why the funding was provided. If I can show you my slide. So the government formulated their agri-tech strategy in 2015, and it was that which was driving them to put up the funding to establish these ag-tech centres, of which Agri-EPI is one of the 4. And one of the major drivers behind that is responding to this global challenge of sustainable food, where we expect the world population to increase to 9.5 billion by 2050. And that's going to require an unprecedented increase of 60 to 70% in food production in only 30 years. And while we're doing that, we need to have less environmental impact than we're having now. So technology's got a lot to do to help to achieve that. And within the Agri-EPI Center, Cassie described how we have this network of satellite farms, and then the red dots showing us the particular centres we have. So we cover the spectrum from fundamental research facilities right through to, if you like, the coalface with our satellite farms, which are very progressive commercial farms out there. As far as the dairy side is concerned, we have 3 dairy sites. There's the one in Somerset, run by Kingshay, the one in Harper Adams University, our Midlands Dairy Research Facility, and then the one we're going to be talking about most today in Dumfries with SRUC. The white dots there are some of the satellite farms that we have that are actually dairy farms as well. So the South West Dairy Centre is looking to harness the power of robotics, automation and sensor technology, combined with state-of-the-art housing and, importantly, precision grazing to optimise cow welfare and productivity. And that's a theme that runs through much of what we've been hearing about today, is the importance of health in the performance of animals. So you can see the building there in its landscape with some of the grazing and the cow track leading to it. And it's just south of Shepton Mallet, and some pretty interesting features to it with its fabric roof, auto feed system, and so on. And if you've not been to see it, when we're allowed to accept visitors again, I would recommend you come and have a good look. The Midlands Dairy Development Centre is another dairy unit, this time for 60 cows with 50 in milk at any one time in the year. And it's a specialist facility for research, particularly on cow behaviour. So this is a joint enterprise with Harper Adams, and Professor Mark Rutter, the animal behaviourist, is very much behind a lot of what we do there. So a single robot, a Delaval robot, and you can see some of the housing features there. So when it comes to the Calf Research and Innovation Centre, the facilities are based at SRU's Crichton Royal Farm in Dumfries, and it's rearing the calves from the famous Lang Hill herd, which is now into its 40th year of selective breeding demonstration there. So not unimportant in terms of the calves is looking after there. But you know, often on an enterprise, the dairy young stock are the least resourced enterprise on the dairy farm. And yet, as we've been hearing from our previous speakers, the vital importance of that rearing phase, which is so essential to achieving longevity in the milking herd, and some really nice targets from Jessica of the key weights that need to be achieved along the way. And that is in order to actually be able to track the lifetime trajectory from birth right through to, one hopes, long-lasting cows. And that term lifetime trajectory, I think it really does reflect what we're all trying to achieve by looking after our animals better at every stage of their lives. So when the investments were being made, Professor Richard Dewhurst was involved very much, and still is, with Agri-EPI. He wanted to be able to put the funding that was made available to him into a young stock research facility, and that sits nicely alongside our other 2 dairy facilities. So I'm not going to go through all of this in detail, but this is the rearing protocols that are followed for every calf by the SRUC team when they're rearing the calves at the unit. So, you know, within a couple of hours of birth, the calf receives 4 litres of pasteurised colostrum, and then is removed from the dam within 24 hours and moved into an individual straw-bedded hutch. And within that, for the first 6 days, is fed twice a day with calf milk replacer, has access to ad lib water and concentrate pellets, and receives daily treatment against crypto. And then on day 7, the calves are moved into group pens of between 12 and 14 calves. And this is where our equipment comes in these larger pens. So these are groups of mixed sex dairy and beef calves, unless, of course, a trial requires a different population. So again, they're medicated. Milk replacer is up to a maximum of 7 litres over the first 9 days, and then maintained at that level through to day 40, and thereafter reduced by 0.4 litres a day to weaning at day 56. So all of that sounds very precise, and of course it can be when one's got equipment that it can be automated and programmed to each individual animal. And here you can see some photographs of the equipment that we've invested in. It's biocontrol monitoring systems. There are 8 pens, each one for up to 14 calves. So we've here got 8 sets of our kit deployed, and there are another 4 that are actually available if need be to be deployed elsewhere if demand for trial work were to demand that. So some of the things we've heard about, again, I very much, Jessica, saying you need to measure and monitor. It's absolutely something at Kingshay that we always live by the mantra of if you measure it, then you can manage it. Once you're managing it, of course, then you can optimize it. And so what we've got here in the equipment is the means to measure individual feed, forage, milk and water intake, and indeed weight gain. So you can see the calf milk replacer feeder on the right-hand side, the cubicle they stand in for each of these different activities, with the weigh cell there that you can see in the middle upper picture, and then the forage intake boxes and mini boxes on the left-hand side. So each animal is identified wherever it goes and whatever food it's consuming. So overview of the building, you can see it's a free-span building, open-sided, with the igloos running down the outside, and then a straw loafing area in front leading up to the different feeding stations. So concentrate intake can be measured, milk and water intakes through those 2 devices there, measured for each individual calf, forage intake, as we mentioned, and the weighing. So the research capabilities of the facility are there to enable studies of calf behavior, welfare and disease. The sensors can be mounted on the animals to monitor still further than what our machinery is able to measure, so anklets and that sort of thing for activity. And indeed, one can look at changes in ventilation and that sort of thing. And there we are, the growth and lifetime trajectory. So the Langhill study looking at this whole story from early life feeding through rumen development all the way to mature animal performance. So I think we've got there a very valuable facility which is available for research, both commercially and funded. A really excellent team with the SRUC team there operating this for us, and us providing the facilities and indeed providing the support to enable projects to be put together and consortia and bids written if necessary. So overview, really, dairy farms for the future. What does the future of milk production look like? What it looks like is there's going to be a lot of more agri-tech than we are even familiar with now involved, because that's absolutely key to long-term business resilience, to enable more to be produced with less impact. And that's a holistic story all the way from understanding about healthy soils and optimizing the health of soils, thereby being able to grow healthy crops. And of course, the most important crop of all is grassland, which covers 60% of the UK land area, and thereby producing healthy livestock by giving them a healthy environment to live in with healthy crops fed to them, producing healthy food. And we've heard a very good case for how good a food milk is today. And not necessarily most important, but very importantly, all of that has to add up to the farmer being able to make healthy profits, to be able to reinvest in that virtuous circle. And we hope that we're going to be playing a major part in doing that with all the facilities that we're making available for dairy research. And with that, thank you very much. I'll finish.
Excellent. Thank you very much. If I can just ask all of the speakers to turn their webcams back on. We have 5 minutes and 6 questions, so I'm hoping for really efficient answers, and I really am hoping to get through all of these questions for our audience today. So I'm going to start at the start with a question from one of Agri-EPI's newest members, Steve Hayden at Aquapulse. This is a question for you, John. As someone learning about the agri sector, could you give us a minute on the importance and impact of water quality within calf health?
Yes, water is multiple impacts, of course, and tends to be, if the calf is the poor relation on the dairy farm in relation to the dairy cow, then water is the poor relation in relation to the other feeds that the calf is being given. You've got microbiological questions, you've certainly got mineral questions. Quite often you've got local use of borehole water, which can be very variable depending on the season of the year. So all of those aspects need to be carefully considered, simply to get back to the basics of having a good, relatively clean water source. And then, of course, there could be other opportunities for novel technologies to take that water story even further.
Excellent, thanks. Yeah, no, very well done, just under. I'm going to move on to the next question. This one's for you, Jessica, from Partha Ray from the University of Reading. Do you expect the effect of early life supplementation on calf growth and health to continue beyond weaning or beyond the duration of supplement feeding? And thank you for your presentation.
Very good question. Yes, we do expect it to very much sort of carry over the effects to how you fed it in those first 2 months of life, and especially sort of when we're thinking about supplements. I think there's a lot that we don't actually see in terms of what it's doing to their long-term development, and this is something that we are starting to do with a lot of our calf trial work that we do at AFBI in Hillsborough, is to actually monitor these calves more on longer term, so actually follow them through until first calving and see what their performance is during sort of subsequent lactations, just so that we can start to get a better picture of those potential carryover effects.
Excellent, thank you. I'm going to move on to a question for you, Duncan, from David Bell. How representative is the Agri-EPI SIUC building with the intake monitoring equipment in relation to that of calf housing in the UK?
Well, I'd like it to be very representative. The answer is that there's a massive range in terms of the level of investment producers put into the young stock rearing facilities that they have. To some extent, that slightly reflects that the young stock sometimes are underinvested in. And whilst what we've got there is beyond what you would want to have deployed on a commercial farm, there's certainly elements of that which are very relevant. So the automated milk replacer feeders and the I think we need to see more in the way of the adoption of regular weighing, and that automated weighing is a really good thing to incorporate, and is now available on commercial machines very much. So it's representative of what I think is an ideal. It's slightly beyond that in that it's set up for research as well. So things like the forage boxes and so on are not something you'd expect to see.
Quite right. I'm just going to ask the speakers. We have 3 more questions. Can you all give me a nod if you're happy for me to continue on past our sort of 3 o'clock stop? Is that okay to ask those 3 questions? John,
Yes.
I'll ask yours first because you're iffy.
Okay.
From David Mills, how do you assess subclinical respiratory issues in calves?
Good question. I think the use of things like the Wisconsin respiratory scoring system has become more common, and people get used to that and being fairly objective with that. And I'm aware of, but not expert in, some further developments around other more advanced technologies, particularly around milk ultrasound. But I think one of the things we're trying to do in this well calf project and other projects going forward is, are there other subtle signals that are easy to measure that we do not yet know could be related to some of those outcomes? And only when we start to accumulate quite a lot of data over quite a lot of trials will we be able to do the sort of statistical work to tease out what could be some of those relationships. So I'm hopeful that that analytical work on data will give some of those answers.
Excellent. And the final question is actually for you, John, as well. And I promise it is the final question. Does the importance of microbiota in young calves have implications for the cleanliness of the housing environment?
I'm not quite sure what the question is getting at there, perhaps. I certainly would not want to say that if you've got a good, well-established microbiota, you can afford to have a dirtier animal house. Far from it. I think all these things have to come together. You know, we have to understand and be able to manage that young microbiota in the context of a nice, clean, healthy house.
So that question there, John, was from your colleague Richard Dewhurst.
Was it now? Right. Okay, I'll have words with him.
Do. That's all we've got time for today. I'd like to say a massive thank you to all of our speakers, Jessica, John and Duncan today, but everybody that's been involved in this sort of mini webinar series that we've all enjoyed. So a huge thank you. You know, we hope we'll bring you another webinar series later in the year. We will send all of the audience a recording of today's webinar, and if there is any questions we missed, I don't think there were, but if there are any, we will pick them up with you after the webinar. So that's all from us. Again, another big thank you, and to everybody, stay safe.
Bye.
Bye.